Dear friends, welcome back to another session on systems engineering. In the last class we discussed about one example of system design. We discussed about a system which can be used for helping the drivers or passengers of an automobile, which is known as AutoLink system. So we tried to see how to use the principles whatever we discussed in the last few lectures. How do we apply these principles to the design of such a system? So we will see another example today. This is more relevant to the institute. This project was done by students. We gave this problem to the students and to apply the engineering system design principles, and then how do we actually develop a system which can be implemented in the institute. So this system is known as INSECTS, which actually stands for Institute Service Kiosk Terminal. The objective of this terminal is basically to provide the services to IIT community, basically as an initiative for IIT's e-service enhancement program. So it is proposed to introduce these terminals at strategic locations to help IITM community and visitors with various services. So we want to provide various services to the IITM community through these service kiosks. This serves as a means for providing support to a user when he is in the institute, and the support will have two major components: the information component as well as the service component. The information component, the system will provide various information related to IIT as well as to the surrounding areas about Chennai, and flight service information, train information, bus information, and all related information about the institute, and then the related services, the related areas. Then the other part is basically providing services. So one is the information part, the other one is the service part. Services actually provide various services to the students as well as the faculty in various aspects of the academic life. We will discuss these, what are the services to be provided and what kind of information to be provided in the system. So based on this, we define the mission of the project and then identify the requirements and then go ahead with the system design. Again, here there can be multiple services provided. So we do not consider all the services in this case. Of course, we can actually add any services to the particular system. So we take a few services and a few information requirements of the system, and then we discuss how do we design the system based on the principles whatever we studied so far. So as I mentioned, the information component will provide the user with information about the institute, place Chennai, and the people at IITM, various location of various buildings, the location and waiting time for buses, etc., as decided by the user. So these are the information component to be provided by the system. And then you have the service component, which will provide the user with services like internet, fax, telephone charges, printer, then paying fees for the students, or this kind of services will be provided by the service component. So looking at these two, we can actually develop the mission for the INSECTS, basically to make the user hospitable in the campus. So it should be able to make an outsider feel independent in the campus. It should also aid the IITM community by providing easy assistance. It should deliver easy info and should be quick and user friendly, and it should provide emergency assistance when needed. So the services basically to make sure that the user or a person coming to IIT, he should feel that he can actually get all the information. He is independent. He do not need to depend on many people for various services or various information. So he will be comfortable in the campus. He can actually go to the kiosk and get all the information whatever he wanted, as well as he can find out the location of the buildings. He can find out the availability of services, and if he wants to make a telephone call, or he wants to make an internet search, or he wants to pay some fees or hostel fee for his wards. So all these things can be done easily using this terminal. So the basic objective is to provide information as well as service to the visitors as well as to the community within the IIT campus. So how do we provide these services through the system? So the mission objectives here can be classified into three: basically online access to various services, academic, administrative, and general to the students, staff, and visitors with various levels of accessibility. So we will be having various services provided in the system, but there will be various levels of accessibility also. So, some of the data can be accessed by students, some can be accessed by staff, and some can be accessed by visitors. So, there will be various levels of accessibility to these services. Then the information regarding location of classrooms, maps and navigational information within the campus will be provided. So, these are the objectives. We need to provide the services, then the information, then utility services like telephone, fax, email, printing, etc. also will be available at this service kiosk. So, we have identified the objectives of the system. So, we have main objectives like providing information, providing services related to academics, and providing general services like utility services like telephone, fax, internet, email, and other utility services like printing and other things. So, these are the main mission objectives of the system. And apart from this, we can actually provide the weather data, train, flight schedule timings. Again, coming under the utility services, you can provide the weather data as well as train, flight schedule timings. Then providing information about the city, maps of Chennai and nearby places, bus, train and road routes in and out Chennai. Then provide information about location and waiting time for institute bus. So, we have an institute bus service. So, we can actually provide the timing of these bus services and what are the points where outsiders can actually get these bus services. Then provide information about people in IITM like the address, telephone number, email ID, etc. for outsiders. So, they can actually do a search in the net or the intranet and get the details of the information about people, especially faculty and other administrative staff. So, what are the general requirements for these systems? We know the objectives, we have identified the mission objectives and the general purpose of the system. So, how do we actually provide these? We need to identify the general requirements. So, general requirements for this system are basically the insect should provide real time services, information and assistance to IITM community visitor 24 hours a day, 7 days a week for the following events. So, we are clearly specifying the general requirements. The system should be functioning 24 hours a day and 7 days a week and providing the services like when the user needs some information or assistance, it should provide. When the user needs emergency help and services, then the user needs utility services like telephone, fax, printout and internet. User needs locations and navigation aid in and around Chennai, and user needs information about Chennai. So, these are the general requirements we can identify. So, we state these requirements clearly because these are the requirement identification stage. When we develop the system, we need to clearly understand the requirements. So, we write down the requirements, what are the basic requirements for the system, like it should be continuous service without any delay or without any break in between, and it should provide the services as listed here. Then we can go for the specific requirements. So, those were the general requirements which actually we can identify from the mission objectives. So, to satisfy these general requirements, we need to identify the specific requirements of the system. These are listed here. The insect system shall have an availability of 0.99. So, the breakdown time should be very less. The insect system shall connect to GPS satellite within 1 minute of switching on. So, that is another specific requirement because we are depending on the GPS system for the navigational aids. So, the system should connect to GPS within 1 minute of switching on. The insect system shall connect to internet within 1 minute on switching on. Of course, these timings again it is up to the designers to decide. So, based on many parameters they can decide what should be the minimum time requirement for getting to the internet or to the GPS system. Then the insect system show location of institute bus within 2 meter of error. So, that is the error allowed within 2 meters it should show the location of the institute bus, real time information should be provided. Then the system shall provide for telephone service for local and emergency calls also. These are some of the specific requirements of the system. Also, the system shall provide railways or airways schedule and status accurate to 0.1% error. The insect system shall provide fax and printout service with an availability of 0.95. The insect system shall provide intranet services for IITM community. The insect system shall have a mean time before failure as 20,000 hours and a mean time to repair of 5 hours. So, within 5 hours the system should be able to come back to its service mode if there is any repair. So, like this, looking at the general requirements, we can actually get the specific requirements of the system, and all these requirements need to be documented as originating requirements document. So, we will see how do we actually convert this into the documentation, or how do we write down the actual requirement based on the general as well as the specific requirements. And again we have to go for the scenario tracing and find out the input output requirements also. So once we have all these requirements, then we will start recording this as the originating requirement document. So these are some requirements, specific requirement, like the system shall provide weather forecast data in coordination with live news channels. The INSEC system shall provide information about Chennai and places in radius of 10 km. Again this 10 km is an arbitrary value, it actually depends on the designer what is the requirement, and then accordingly write the requirement. The system shall provide information about local transport, the bus routes, train and road maps in the Chennai, and then INSEC system must provide maps and navigation about IATM to visitor. So this is again an important part. The system should be providing the navigational aid to the outsider. So whenever he wants to go to a particular place in IIT, he should be able to locate himself in the map and then identify the route to the desired building or desired facility, and then how to reach there, and this actually should be linked to the bus service availability and the present position of the bus and the expected arrival of bus to that location. So all this information should be available in the system to help the visitor. So let us look at the system design aspect. What we discuss about the system V, basically we look at the system design from the system V process. So as we discussed earlier, that we can actually develop a system V diagram to show how we actually go ahead with the design of the system. So in the system V, the process is like a V. So we start with the disintegration of the system and then we go for the integration. So we start with the mission statement, user wants and needs plus emergency requirements, which we already identified some of the requirements, and then we go to the next level where we identify the machine level inputs requirement, user power, maintenance and interfaces, then GPS, internet and intranet requirements, and then we go for the requirements of characteristics and attributes of and the specifications of the individual components needed. So we will be defining the system, and in this, by defining the system we will be identifying the machine level requirements and the characteristics and attributes of various components, then their specifications, and then we go for the system subsystem or subsystem design requirements and specifications. And here we will be taking many the requirement cascade and the feasibility functions will be taken into account, and they will be interacting to get the system and subsystem design requirements and specifications. Similarly, we will be going for the details of the parts and components. Once we identify the system and subsystem, we can go for the part and component design specifications. So here we develop the individual components and parts for the system, and then we will go for the fabrication of the system. The component fabrication, part and component fabrication and verification will be done, and once these parts and components are verified, we will go for the system verification and then fabrication of the first prototype from these components. So we will start with the integration of the system and make the prototype, and then we go for the verification and production and testing of the complete system. Based on the qualification test, we will decide to go for the update or updating the system, and finally we will be providing this to the customer and you will be getting the customer satisfaction. So this is the system V diagram where we start with the identification of the requirements, and then we go for the concepts for the system operation, and then we discuss about the other requirements like emergency requirement, maintenance requirements and all other requirements, and we go for the component identification, component and subsystem identification will be done, and then if needed we will be designing components and subsystems, and then fabrication of this will be carried out, and then integration will start. We will start assembling these components and then make a system with a few terminals, and then do the trials and qualification testing will be carried out. Based on the qualification testing, we will be updating the system, and finally it will be given to the user for using. So that is the process of development of the whole system. So from the identification of the requirements till the delivery of the system with many terminals in the system, that will be the complete process, and once it is accepted by the customers, then that actually completes the design process. So, this is the way how we actually go ahead with the system design. We will not be going through all these stages because the integration, qualification, etc. are all depending on the actual system developed. So, we will be looking at the disintegration. So, we will start with the context diagram. The context diagram basically tells you what will be the approximate concept that you will be using for designing the system. So, this actually will identify the external systems and what kind of interactions are taking place between the terminals as well as the users. So, all these will be identified in the context diagram. So, this is the context diagram. So, you can see that the terminals will be at different locations provided in the campus, and there will be users from inside the campus as well as from the outside the campus, and there may be different databases which will be connected to the system, basically the database about the IIT facilities and the locations of the various buildings, etc., and there will be an internet connectivity to the system, and then for utility services like fax, printer and telephone will be available with every terminal, and there will be a emergency support service. There may be a customer support service directly connected to the terminal. So, in case of an emergency, the customer support will be activated, and then we can get the emergency services. Similarly, there will be other features like the connection to the GPS system. So, you will be having a satellite or GPS connection, and then we have the other information like flight services or train services, and then we can actually add some features like delivery of some equipment needed for the institute or the students. So, if needed, that also can be connected. So, these are the possible external systems that you can have. This is the context diagram for the system, where actually we identify all the requirements or all the systems which need to be connected and what kind of interaction needed between these systems. So, based on this context diagram, we will go for the detailed system design. So, we will look at the scenarios under which the system will be used. In order to identify the input output requirements, we go for the scenario tracing and getting the requirements. So, in order to do this, we will consider various operational scenarios. So, as you know, the operational scenarios varies different situations. So, we will look at the various scenarios. So, one scenario we can identify is that the visitor uses insects to find the directions in IITM campus. So, this is one of the scenario. So, we will go into the details of the scenario and then see what are the different activities the operator will be carrying out, and accordingly we identify the requirements. So, here we start with the visitor switches the device on. So, assuming that the device is switched off, we will assume that the visitor need to switch on the device, and the feedback will be given that the device is switched on, so that the customer will know that it is in on position and can actually provide services. And then the feedback request type of user, that is the system will be asking for a feedback requesting for the user type of user, whether he is an inside visitor, inside person or a visitor from outside. So, that information to be provided, and depending on that user selects an option, and then the option will be provided in the system for the user to select what actually the requirement is. So, here the option to get directions and locations of various buildings in IITM campus will be selected by the visitor. So, the system has to display all the options for depending on the status of the user, whether he is a visitor or IITM community person. So, accordingly we will be having different options, and then the user can actually choose the option. And then the feedback device will show the current location and important landmarks in IIT campus. So, the current location of the person will be shown, and then various other important locations also will be shown on map. Then the request direction from one location to another, then the user can actually request for direction from one location to another. So, this actually shows that the system should be capable of taking a input from the user to give the input. So, there should be a provision in the system to take the input from the user to give this data input. So, the location, so he has to choose the location where he wants to go, and then he will be getting a feedback about the directions from one place to another place. So, this direction will be shown on the map or what any form of feedback, either in the form of map or a kind of a printout will be given as a feedback. And then feedback on option to print map of IITM campus. So, if he wants, he can actually print the map, and then user selects the option to print the map, and then the feedback map with the desired direction is printed and the important landmarks highlighted. So, again the feedback will be given to the user that the map has been printed with the landmarks highlighted. And if the user is satisfied, he logs off and then logs out from the system, gives a feedback that the customer is logged out, and the feedback the user has been successfully logged out of the network. This is the series of activities taking place when the user asks for a help from the system using for the purpose of navigation within the campus. Like this, we can actually identify multiple scenarios, and for each scenario we can develop this kind of a detailed tracing of the scenario, what kind of activities are taking place in executing one particular scenario. So this is another scenario where the user uses insects for accessing the internet. So what are the different stages or different activities involved in the accessing this particular service. So user switches on the device, then feedback that device is switched on, then the feedback request type of user. So this will be the common for all the applications, because every case the system has to identify the user and whether he belongs to the IITM community or an outside visitor. So accordingly you can actually the options will be given by the system. From here he can actually, if it is for internet service, then we have to provide the username and password for accessing the internet service. Then user enters username and password and feedback the user is logged in, and if password is correct, otherwise it will be going to another loop where the password is not correct. Once he is logged in, then he can actually select the internet option and then feedback that internet has been connected and he can use the internet as per desired. And then again the logging off will be similar to the previous scenario. Once he is satisfied with the service, he can actually log off, and then the feedback will be given that he has logged off the system, and that actually ends that particular scenario. So here by the idea of having this kind of scenario tracing is to find out what are the different requirements you can identify from these scenarios. In this case we know that there should be a feedback that username and password to be given. So for this particular service you need to give a output from the system or a feedback from the system requesting for the username and password. So if that is correct, then only the person can actually access it. So similarly these activities gives some other requirements like the feedback what is needed. Similarly how do we actually enter the data, how do we actually identify the person, whether it is a password or it can actually have some other kind of option to identify the user. So these kinds of requirements can be easily identified using the scenario tracing. So here again this I already told you that how do we actually come out of the system, that is feedback is given, logs out when finished, and the feedback user has been successfully logged out of the network, that actually completes that activity. So this is another scenario again for making a phone call. So what are the stages through which the user will be going through in order to get that one. So here again the first two will be the same, then the user selects a telephone option, then feedback the telephone is activated, then feedback telephone asks the user to insert coins if it is a coin operated system, or if it is a card operated, then the options will be different. So again here the designer has to make a choice whether what kind of a system should be provided or what kind of facility to be provided for activating the telephone service. And then feedback dial tone is switched on, the user dials number and feedback sound of numbers being dialed and call being connected. So of course this is part of the telephone service, so we do not need to have a requirements identified for the phone. Once it is connected to the telephone network, then all these things will be automatically taken care of. And this is basically how do you end the telephone conversation. If it is basically activated by the coin or the card, then there will be some feedback about the timings, and once the money is finished or you want to add more money, of information will be provided. And once the user finishes call and places back the receiver, then there will be a feedback that telephone line is switched off and call is disconnected, and then user switches off device and feedback device is switched off, that will be given as a feedback. So these are the various activities for that particular action. This is another one similar to the previous one, that basically sending or receiving a fax document. Again most of the initial activities will be almost same. Instead of telephone he will be connecting to a fax option, and then fax service will be provided. So here we need to see is how do we actually provide the user with some facilities for feeding the paper and then directly connecting to the fax machine, and then once we give the feedback that it has been completed, then actually we can log off similar to that of the telephone service. So again the idea is to get all the activities noted down or recorded, so that we can see whether any particular additional requirement is to be provided in the system to meet that particular service. So this again the same, the fax service. So how do we actually identify the requirements for fax machine fax service? So what are the various stages to be identified? This is for the railway or airline status or schedule information. So here actually the user will be selecting an option of this available in the system, and based on that the required information will be provided. If it is a paid service, then he will be asked to pay the money, otherwise the information will be provided to the user. When the user requests the schedule, the feedback will be given about the train or air services, and then based on the feedback again he will be giving the details, and then user requests the reservation status of the ticket if it is booking a status inquiry, and then feedback on connecting with the server and reservation status is displayed, and user is satisfied and switches off the device and device switched off. So that is the activities carried out by the user when he is using this particular service. Again another one is printing the data. If he wants to print a particular data from the system or want to make a printout of some data provided by the user, again that will be options provided by the system. So user can select the printing option, and then there will be a feedback that the printer is activated or not activated. So if the printer is not in operation, then there will be a feedback given that printer is not available. Otherwise he can actually use the printer, or the feedback will be given that the printer is in working condition, and then the input data will be given, and then user gives the data and feedback asks for number of copies, and user enters the desired number of copies, and then feedback type of printing, and whether it is a color print or a black and white print, that kind of options will be provided, and then feedback printing data is done after completion, and then user switch off device and the feedback is device is switched off. So again some of the things can actually be combined to the printer functions, but in the initial stages we need to identify all the activities so that we do not miss out any of the requirements of the system. So that is the idea of giving all the details of the particular activity. Again like this we can actually identify many scenarios. So here it is about the weather condition. So in the weather condition also the same situation applies. Here actually you can give the option. So the system will be giving various options, then the user can actually give the option that he wants to get the information about the weather, and then the different options will be given whether he wants to get the weather condition in this particular location or some other location. So when he gives that information, the system will collect the data from the database, or it will get the data from a live resource available where actually the updated information is there, and that information will be displayed to the customer, and the customer will if he is happy with the information he will log off, or if he wants to get more information, or if he wants to create a printout of the option, then he can give a printout option, and then he will be switching off the device. So depending on the situation there will be multiple options available for the customer or the user. So depending on those scenarios there will be different activities identified. So we need to look at all the possible options and then identify the scenarios, that particular scenario, and then see what kind of additional requirements are needed for those scenarios to be satisfied or to satisfy those requirements of the customer. So once we have these scenarios identified, the next task is basically to look at the input output trace of the scenarios. So we discussed about many scenarios, so we will just see how do we actually write down the input output scenario or input output trace for the system. So this is for the first one to get directions in IITM campus. So we can identify the insect as the main system here. So this is the main system insects, and then we have the user here. So user is the one which actually interacts with the system, and then we will be having an additional depending on the situation we will be having an additional external facility also, like a GPS. So an external system which will be interacting with the insects. So these are the three entities in this particular scenario. So we can see what kind of input and output is going on. So the user actually will do the switching on the device, and then we will be getting an information that the device is switched on. So this is an input to the insect, and this is an output from the insect. So you can see this is an output and this is an input. So like this we can actually look at all the activities whatever we explained in the previous scenarios, we can actually identify what kind of an input is coming and what kind of an output is going. So this is an output, again the information that the device is switched on, then he will request for the type of user, again the system will ask for the type of user, then the visitor will give that information as an input to the system that it is a visitor, and then he will give an option, the system will give an output giving various options to the user, and user will select the options, and then it will be the data will be provided by the system, the map and other information like the current location will be given, and then the user can choose the destination. So it will ask the system to the user to select the destination, then the destination selected information will be provided, and then all the possible routes will be displayed by the system. So that is the output coming from the system to the user. So the arrows represents the data flow from the insect to the user. Same way all the scenarios can be traced, and you can actually see the information to print map will be given by the user, then the map printed information will be given by the system. And here also you can see the insect will be interacting with the GPS system. So that is another external system here. So the GPS data will be downloaded and the maps will be uploaded using the GPS data, the current location and other information will be obtained from the GPS data, and that will be given to the insect system, and then using this data the system will inform the customer about the location and other details. So this is how the interaction takes place between the user, the system as well as the external system, the GPS system. So we identify using this input output trace, we try to identify the type of interaction taking place between the system as well as the external systems, and then try to identify what kind of requirements are there for these things to happen, and accordingly we need to design the system. So that is the importance of input output trace. We will try to identify the requirements for those scenarios based on the input and output. We will try to identify those requirements and then write down those requirements as the originating requirements. So this is for the other scenario, access the internet. Again if you have the scenario for accessing internet, you can see that insects the system, and then you have the user as the external system, and then you have the database or the server as the another system which the insect will be connected to for the internet. And here this shows that the type of inputs, user gives an input and the system gives a feedback. Similarly you can see that the type of person who is that is the internal person or an outside visitor, that information will be given, and then the username and password data will be requested, and then it will be feedback will be given, then it will the feedback about the authentication will be given, then the request for internet connection will be given by the user to the system, and then you will get a feedback that the connection is established, and then using the net by the user, then feedback will be there about the necessary about the desired functions in the internet, whether he wants to do any particular activity, and once he completes the activity he will be logging out, and then there will be a feedback that the user is logged out, then you can switch off the device. And here you can see the interaction between the system as well as the system with the server will be basically to get for logout purpose as well as for the internet connection and the authentication of the user. Based on the database, the user will be given a connection whether it is based on the username and passwords, and once it is accepted then the connection will be established, and then only for logging out he will be again connecting to the server and gets a logout from the server. So this is how the input output trace for the second scenario looks like. Same way we can actually develop many scenarios like for a telephone service. So we can in the telephone making a phone call, the user is one system, external system with the insect, and then you have the insect as the main system, and then the telephone exchange as the external system. So when the user gets the options, gives the option and then gets the connection, then it will be connected through the exchange to the system, and then if it is depending on the payment options, so these activities will be there. If it is not coin, then it will be a card access mechanism. So depending on that, we need to identify what kind of interaction takes place. And once it is connected, then the telephone, it will be connected to the telephone exchange. Through the telephone exchange, you will be provided with the service that is shown here. There will be a request for the telephone service from the terminal, and that will be established by the telephone exchange, then it will go to the next level. So that is the that is how the input output trace for the this particular scenario looks like. Now once we have all these requirements, the next task is basically to write down the originating requirements document. So various requirements like general requirements and the specific requirements, and then we find out identified the various scenarios and the input output requirements. So based on this, we can actually start writing the system originating requirements document, or the ORD. So in ORD, we start with writing the system overview. So we will write the insect system shall provide information and services for personal and commercial use to its user about the campus of Indian Institute of Technology Madras. It shall provide information reliable more than 95% of the times and can cater to at least 5 and no more than 20 centers around the campus, with each center managing up to 50 users at a time. So this is the general overview of the system. So what is the purpose of this system, and what are the expected service standards from the system to be given as an overview, as an introduction to the ORD. And then we will write down the applicable documents. What are the documents which are applicable to particular this system design. So we look at the standards existing for various applications for communication, as well as internet service, telephone service and similar services, and then we write down all those documents and document numbers and the names here as the documents applicable to the system development. Then we will write down the operational phase requirements. So we can actually have different requirements depending on the phase, as we know that there are various life cycles. So for that, those life cycle, we need to write down the requirements. So we are looking at the operational phase requirements here, the input output requirements. So we are giving the numbers like this for 3.1 as the input output requirement, and in this one we will identify the input requirement first, and then the input requirements for input from the users. We write the system shall receive 99% of the queries from users. The system shall receive 99.99 emergency requests from users. Then the system shall receive 95% calls for bus timings and routes, and system shall receive 99% requests for directions. So these are all we identified in the specific requirements. So that will be, we are writing in the systematic way in the ORD. Same way, the system shall receive 99% requests for utility information. The system shall receive 98% requests given when asked by a phone, internet or subcenters, and the system shall accept requests 99% of the times. Then requirements for inputs from the maintenance personnel. So there will be users, maintenance personnel. So there may be various users. So these inputs are for the maintenance personnel. So you can see the system shall receive 75% of all routine maintenance calls within 5 hours. The system shall receive 99% of all diagnostic signals. The system shall receive 99.9% of requests for diagnostic log files. The system shall receive 60% of all repairs within 4 hours. And the system shall receive 99.99% of all data during test runs, irrespective of the type of request. Then the inputs from primary server requirements. The system shall receive 95% of queries from primary server during peak load and 99.9% otherwise. The system shall receive regular updates from the server 99% of the times, and then the system shall receive requests from the main server 10% of the times in standalone mode, and these requests will be used to regulate this mode. Then the system shall receive 99.99% of on-off calls from the server. So these are the requirement inputs from the primary server. Then the output requirements. So what we discussed was the input requirements. Then the output requirements, again we can classify from the user outputs, then the maintenance personnel or all other users. So here the output requirement from to the user are the system shall provide a minimum information to the user within 10 seconds 95% of the time, and design goal is 5 seconds. So within 5 seconds we should be able to provide most of the information. the system shall provide the user with a network timeout error or failure feedback in case of failure. So, it should be able to give a failure specified here. So, that should give a output like what is the feedback should be given about the network timeouts, and system shall continually display emergency routine when necessary. The system shall provide services even during periods of maintenance. So, that is another requirement. So, during maintenance also some services should be provided. The system shall show real time usage, traffic and information flow rates to the user, and the system shall provide feedback 99.99% of the time to acknowledge query acceptance to the user. And again the system shall continually show its state of connectivity with the primary server, internet, database and satellites for the user's convenience. System shall show estimated recovery time in case of system failure or maintenance or both. The system shall give both hard copy and soft copy responses to the user query, and depending on the response from the user should give a hard copy or soft copy or both. This is again to the output to maintenance personnel. The system shall provide diagnostic response that are correct 99.99% based on diagnostic signals. The system shall provide test results that are 99.9% correct. The system shall immediately give malfunction signals that are correct 98% of the times. The system shall provide feedback to the personnel 99% of the time to acknowledge their request. Then the requirements for output to the main server, the system shall provide output to server calls 99.9% of the times. The system shall regularly update the database 99.99% of the times. The system shall report of performance drops and traffic data to the server once every 10 minutes. Again this actually depends on the designer about the 10 minutes. So, depending on the request or the service requirements, this can actually be decided by the designers. Then the external interface requirements, the system shall receive power from the location's main power supply using ISO based standard connections. Then emergency phone, the system shall have an emergency phone with limited outgoing ability to be used in case of emergencies. And then GPS, the system shall have direct access to GPS satellites to improve data transfer rates. Backup power requirement, the system shall have a backup power unit in case of power failure. In the functional requirements, the system shall accept user requests and provide feedback. The system shall provide up to date and accurate data. The system shall provide reliable connections and data transfer rates. The system shall enable effective maintenance. In technology requirements, the system shall require accurate GPS tracking system. Then the internet, the system shall require fast and high bandwidth internet facilities. Then the system shall cater to all the relevant fire and safety codes, that is the suitability requirement for the system. Then the system shall adhere to all the central, state and local laws in place. The system shall have an MTBF or greater than 10 years, the design goal is 17 years. The failure is defined to be a complete inability to cater to any queries of the user. The system shall have an MTTR of less than 5 hours, the design goal is 3 hours. Repair means the system is returned to full operating capacity. So, within 3 hours or within 5 hours the system should be able to bring to the normal operating modes. The cost requirements, the system shall run at less than rupees 5,000 per month, the design goal is rupees 3,000 per month. In the schedule requirement, the system shall have an expected life expectancy of at least 30 years, that is the life expectancy requirement. So, once we have this we need to go for the functional decomposition. So, what we discussed so far is about the requirements identification, and once we have all the requirements identified, we will go for the originating requirements documentation. In ORD we will write down all those requirements, whether it is the input output requirement, system wide or technology requirement or the functional requirement. All those requirements will be recorded in the ORD for in terms of the life cycle. So, for the operational phase, the retirement phase or the maintenance phase, we will identify all these requirements and write down these requirements as the originating requirements document. So, that is the first stage of the development of the system, and the next stage based on these requirements we will go for the identification of functions to be provided in the system. So, this we will do through functional decomposition. So, we discussed about many methods for functional decomposition like Hartley-Pirbat template and IDEF0 diagram. So, we will use the IDEF0 diagram and then see how actually we can decompose the main function into small functions and identify the small functions to be provided in the system. So, this we will see in the next class. We will look at the functional decomposition and then developing the functional architecture as well as the physical architecture, and then developing the system. We will look at the details in the next class. So, till we meet, goodbye.